In this issue of Spacecraft Guide, we are going to continue showing you how the space shuttle flies in outer space and how you control it. And also at the end, we're going to show you how you could win your chance to get your name associated with a time capsule that's going to the surface of the moon. So for this issue, though, we are going to continue to work on the reaction control system, and we are going to go into an indicator up here on the forward reaction control panel right up here, and we are going to focus on the forward helium talkback. And when you click on it, it takes you to the forward reaction control system helium talkback, which is right here and right here. Now, what these talkbacks do is they show open or closed. You can see open here. These valves are open. When the pair of valves is open or closed and open or closed and barber pole. And remember, that is aligned, it's white with a gray or black line that goes down this way. And that is to indicate that the valves are in transit, or one valve is open and the other valve is closed, or some micro switch failures. So this is going to indicate that, hey, you did open up a forward helium, RCS helium switch, which is right below here. Here you can see we have the helium for the oxidizer coming in this way and here, and then the helium for the fuel coming this way and this way. And then if that valve is open, then you can see the line that it comes down from the switch. So what the switch is open here, because that's indicating the talkback is indicating open. The switch is in the open. If it was in closed, of course, this would be CL. But if the valve was in transit, like if it's moving or is stuck or there's a problem, then this would be the barber pole. And when both valves, helium fuel and helium oxidizers are open, the talkback indicates open. When both valves are closed, the talkback is closed. If one valve is open, the other is closed, the talkback indicates a barber pole. So you might get some of the pressure coming here from the helium or helium oxidizer or fuel oxidizer, but one of them is not working. You don't know which one until you start looking at the pressures. So that is what we're talking about here. So that's all for this week for those people on YouTube. If you join my Patreon, we're going to go into the schematics. If you join the paying side, we're going to go deeper into this talkback and how it works the way it does. So if you are a subscriber to my Patreon page, which is free, which means it doesn't cost anything, and you click on schematic, it goes right to, here we have the forward RCS schematics, and this one is, as you can see, for the fuel oxidizer. So we have the helium tank here, and we have the helium pressure with the dual regulator. So we have the switch that is right here turned on, and then we have the regulator here, and then this box right here, if we follow it down here, that's the pressure indicator. And what it's doing is like, okay, now we're going to check. This is the way that where the valve is, and this is the fuel, or the helium pressure are coming through, and we're going to see if we have any, and then it's going to compare to the actual pressure in that line, and that is all going to work on the talkback. So talkback is right in here. All of these things work together to tell the pilot, or tell the astronaut, where that valve actually is positioned if he knows where it's positioned, or if there is a problem with this system. So that's all for the talkback. Now, if you were a paying subscriber for the for Patreon, we're going to go a little bit deeper into another spacecraft system. And if you are a Patreon paying subscriber, we are going to go into the North American Aviation X-15 flight manual. This is where it all started. So we're going to go down into here, into the cockpit. And as we see over here, we're going to look down here to number 10. Number 10 here is the engine throttle. Now, it was a rocket engine, but it was throttle. It had a throttle, which means you could control the power. Now, that is a first for rockets, because usually the other rockets, you just launched them and they went. This one, you actually controlled it. And if we come down here, you can see here's the throttle for controlling the amount of hydrogen or helium that's going to pressurize the system. You can see the helium here, and you can see the valves going here. But what that pressurizes, you see over on here, that's the ammonia tank. And then on the other side, it had the liquid oxygen. So here is the helium. And this helium entered into these valves here. And you can see that the helium is going to come into this tank here, which is where the liquid oxygen is, and push the liquid oxygen to the main feed valve. So that was the liquid oxygen. Now we have the same thing for the ammonia. We have the helium pressurizing that ammonia tank. And because it's doing that, it is going to, the helium is going to come in and pressurize that system. And then here we go. We have the liquid oxygen on this side, and then we have the ammonia from this side. So it's coming into the system and going to the main chamber for our thrust. So the throttle is actually helping control the flow of the mixture of of the ammonia and the liquid oxygen. So that is basically how the first rocket plane, rocket ship, flew with a throttled engine. So this is basically what the shuttle engine is doing. But you got to remember, these engines on the shuttle that we were discussing, those were reusable. They took them apart and put them back together again. That's because NASA wanted to make sure that the engine didn't break down, that they wouldn't have any failures. Those engines were used over again. The tanks were used over again. The only thing that wasn't is the large external tank. The boosters, the solid rocket boosters, they came down, they were reused. It was only that center tank. That was the only thing that didn't make the space shuttle reusable. So and that's why the space shuttle was the first reusable rocket space plane, even before SpaceX. So I hope you enjoyed that explanation. I hope you enjoyed going back into the history of where the shuttle engines got its logic from. And again, I hope you enjoy me explaining this. And I really want to say my appreciation for all of you that are helping get the word out about my page. We have the contest going, and we have the leaders coming up on it. Not much change this week, but let's see if we can't change that. We got a couple more months for the contest. So just wanted to let you know that I have been watching, I am appreciating, and for all of your help, for all of your support, for all of your spreading the word, I thank you.